Good morning, class. Today is Thursday, May 21st. Let's begin with some science. Okay, so the first thing I want to review before we get into the weeds of our new science today is I want to review all the songs from this unit. So make sure you're learning these. I know it sounds cheesy, especially in a recorded video, and I'm not particularly happy that there's a million YouTube videos of me singing now, but it is important, and I'm doing it because I really want you to learn. So let's do this together. Excuse me. So we have two major types of energy. Remember, everything in the universe can be divided into two categories. There's matter, which is a fancy name for stuff, and energy. Two things in the universe, they are matter and energy. Okay, so we said matter can be divided into four categories: solid, liquid, gas, and plasma. And they can change in between those categories through physical and chemical changes. Let's review those four categories together. And the physical changes that kind of change in between them. Liquid to a solid is called freezing. Solid to a liquid, it melts back again. Liquid to a gas is called evaporation. Gas to a liquid is condensation. Awesome. So now we're moving over to energy. Energy has two major categories as well. Energy can be potential or kinetic. All of the other categories of energy come after that. We remember this as potential is kind of the getting ready energy, and kinetic is the energy of motion. So we have potential, kinetic. One more time, I want you getting out of your chair at home. We have potential, kinetic. Super. So now let's review our different types of energy. So we have potential and kinetic energy. Then we can divide energy into more specific categories after that. So singing this song, 1, 2, 3. Mechanical is energy of movement. Electrical is the flow of electrons. Chemical is in food and batteries too, stored in chemical bonds. Sound needs matter with vibrations. Thermal is heat like the sun in the sky. Radiant is light that travels in transverse waves, bouncing to our eyes. Awesome. Let's do that one more time because I know you need to practice. That's probably the harder song to learn. 1, 2, 3. Mechanical is energy of movement. Electrical is the flow of electrons. Chemical is in food and batteries too, stored in chemical bonds. Sound needs matter with vibrations. Thermal is heat like the sun in the sky. Radiant is light that travels in transverse waves, bouncing to our eyes. Amazing. And I'm sure you're singing at home, and I'm complimenting you on your amazing singing at home. Let's review our electricity song. And I'm warning you right now, we're probably going to do this twice because it is complicated. So we have electrons flowing past. Series has one single path. Parallel has two different ways to keep the light. Series electrons flowing about. One resistor goes, the rest go out. Parallel has two different ways to keep the light. Circuits can be open and closed. Switches make it stop and go. Resistors use electricity like fans and lights and radios. Conductors allow electricity to flow like water easily. Conductors made of metal like a wire. Insulators block electricity. Plastic wood, no energy. Insulators like rubber on tires. One more time. I told you, I promised you we'd be doing it twice from the beginning. Again, this is very helpful stuff, especially for 6th grade. That's why I'm hitting it so hard right now. 1, 2, 2.5, 3. Electrons flowing past. Series has one single path. Parallel has two different ways to keep the light. Series electrons flowing about. One resistor goes, the rest go out. Parallel has two different ways to keep them bright. Circuits can be open and closed. Switches make it stop and go. Resistors use electricity like fans and lights and radios. Conductors allow electricity to flow like water easily. Conductors made of metal like a wire. Insulators block electricity. Plastic wood, no energy. Insulators like rubber on tires. Fabulous. I'm so glad my singing voice is everywhere now on YouTube in like 100 videos. Wonderful. Let's continue to move on to something else. So today we were supposed to do our conductors versus insulator with electricity sticks. I'm sorry to tell you, I was a cotton-headed Eddie Muggins and completely left my electricity sticks at school. So I am going to post a video of someone else using the electricity sticks and doing kind of a similar experiment. And I'm also going to give you the results from last year's experiment. So let's get started. Oh, why is it doing that? Okay. Oh, we'll just go backwards. So the first thing we're doing is we're identifying the question. Which of the following materials are conductors? So imagine conductors allow electricity through them. Which ones are insulators? I predict that blank will be good conductors and blank will be insulators because. Pause this video at any point if you need more time to fill any of this out. Then pause this video, make sure you fill out the type of data, independent variable, dependent variable, constants. If you're listening to this video now, I'm assuming that you've paused the video and you filled in all that information and you're ready to move on. The independent variable, what we're testing is which material is going to complete our circuit. Our dependent variable, how we're measuring it, is whether or not our electricity stick lights up. Our constants, what we need to keep the same to keep the experiment fair. Last year when we did this in my class, I made sure we had the same people, the same number of students in our circle, etc. Okay. So now for the lamest lab of all time, I'm so sorry. I'm just going to tell you the answers to what we got last year. Cloth is an insulator. Book is an insulator. So you should be filling out all these things on the conductor insulator column. Water, believe it or not, is a conductor. Conductor. We talked about this yesterday. This is why you don't want to be in a swimming pool when it's lightning outside, because that lightning is looking for somewhere to hit. And if it hits that water, which is a giant conductor, and you're in it, you are going to be electrocuted, which is not fun for anyone. A mirror is actually a conductor. And the reason mirrors are conductors is because they often have a tiny piece of metal, which gives them that reflectiveness. A wooden ruler, we said plastic wood, no energy. So wood is not a conductor, not a conductor. It's an insulator. A paper clip is metal, mostly made of metal like wire. So this is a conductor. Okay, moving on, our next two. The banana is always my favorite. I'm annoyed that I couldn't do this lab with you today. But a banana is actually a conductor. And the reason for that is a banana is made mostly of water. And water is, as we just said, a conductor. And so that's why it allows electricity through it. Toys, it depends on the toy. Usually I bring in one that isn't made of metal, so that is an insulator. And a coffee cup obviously doesn't have any metal in it. It's meant to be an insulator. And I just want to show you here with my coffee cup, okay? And it is protecting my hand, right? I don't want my coffee cup to be a good conductor. You don't see too many coffee cups that are made of metal, or at least completely made of metal. And that's because if this were all metal and I put hot coffee in it, it would transfer that heat to my hand and I would burn my hand. The fact that this coffee cup is an insulator is actually a good thing because it protects my hand from getting burned. We don't want that heat energy to transfer to my hand. So was your hypothesis correct, verified, or incorrect, falsified? And then you need to graph here. You should use a bar diagram because we have two different columns. And then you should probably skip count by twos, and you should write the number of conductors versus the number of insulators. Then we need to fill out this graphic organizer that says conductors, insulators, or both. So what characteristics, which items belong to conductors, which items belong to insulators, which items belong to both, what characteristics are there of both? So for example, something I would put in the both category is they're both matter, right? They're both stuff. They're all solids, liquids, gases, and so they would both be matter. Another thing is, so So some characteristics of conductors, they're usually metal. Conductors allow electricity. So they allow electricity. They're mostly metal. Wire is an example. Bananas are an example. Water is an example. Any of those things. Insulators are things like coffee cups, air, anything like styrofoam, ceramic. These things don't allow heat or electricity to pass through. So that is why they are insulators. Okay. So now we're going to be doing the hop, skip, jump. You need to take all of the words from the word bank and match them to the pictures that you see. I'm going to go over these answers in 3 seconds, so make sure that you pause this video, you answer them to the best of your ability. Okay, so if you're listening now, I'm assuming you've paused and that you are ready for the answers. So this first one that shows a single line with 2 light bulbs on it, and I'm actually going to transfer these images to more of a circuit diagram, mostly because my drawing skills are terrible. So we have a circuit here that has 2 resistors. Now, think about it. If I was running on this path, do I only have one way that I could go, or are there more than one way? There's only one way I can go. So series have a single path. So that is a series circuit. The circuit to the right shows 2 light bulbs, but there's a line in between my 2 light bulbs. I know this isn't an exact image, but we get the idea. From here, I have many different paths, right? I could go that way. I could go this way. I could go this way. So when I have many different paths, that is parallel. So number 1 is series. Number 2 is parallel. Number 3, we showed 2 magnets coming at each other, but are they sticking together? No, instead, and it's showing me 2 of the same field together. So if you have 2 magnets at home and you try to put them together with the same side facing, they push away. Like this is called repel. Repel is the answer to number 3. The one directly under it that shows a magnet with 2 ends, those 2 ends are actually called poles, just like how the Earth has a North Pole and a South Pole. Our Earth is like a giant magnet. So these 2 things that are connecting it together, these are the poles of my magnet. They can be north or south. The one that shows a screw with a battery, this is actually an electromagnet, and the whole point of electromagnets is to show that there's actually some magnetic properties to a current. So when we have electricity going through something, it actually acts like a magnet in some cases. Our next one, slightly to the right of it, we say circuits can be open and closed. Switches make it stop and go. So if you notice, the switch is open on this one, and my light bulbs are off as opposed to on. So this is actually an open circuit. The one to the right is fans and lights and radios. So it's a resistor. It uses electricity, right? You can't have a light bulb without electricity lit up. And then the last one, the one to the right, you see how those arrows are coming together. We see that there's 2 different poles coming together. This is attract. So when 2 magnets are coming together, it's called attract. When they're coming apart, it's repel. Attract, repel. Attract, repel. Okay? So this part is really difficult. I just want you to take a good guess. Which of the following circuit diagrams would work if created as shown? Circle those that would work and put an X on those that wouldn't. I want to go over a couple of terms. So if you see something that looks like this, like a giant mountain squiggle, this is a resistor. So something like a light bulb that would turn on. If we see this specific design, this is a specific resistor that's a light bulb. A line is just a piece of wire. If there's a break in that line, or the line looks like this, it has a switch that is open. If I have a switch like this, my switch is closed. If I have a transistor that looks like this, that means the electricity is flowing in the direction of this arrow, right? So the electricity is going this way. All batteries, which a battery looks like this on my circuit diagram, have a positive and negative side. It needs to go from the negative side to the positive side. So if this arrow is going the other way, it's not going to work. Do the best that you can. My resistor also can't be next to my battery. Do the best that you can. It's okay if you don't get it. Then, most important, I want you to draw a picture for circuit, conductor, insulator, and resistor. Thank you so much for joining me today. I hope you learned something. I hope you enjoyed practicing and singing with